Blessed day, everyone. I'm Ofelia Orate, a principal owner of a school and a tutorial center, a math teacher, and an author of 21 books. Welcome to my channel, Math with Mrs. O. Please don't forget to subscribe and click the bell button before we start. Okay, so our lesson for today is graphs of linear inequalities in one variable. This was actually requested by some students, so I'm uploading it for them. So problem number 1, x is greater than 7. When you are graphing linear inequalities and you are using the inequality greater than, then you have to use a whole greater than and less than. Use a unshaded whole. So if it is x is greater than 7, let's say this is 0, and let's say this is 7 here. So you have your 1, 2, 3, 4, 5, 6, 7. Greater than 7, you put a hole here, and then all numbers to the right, meaning 8, 9, 10, and so on and so forth are included. You always use an unshaded hole here to denote that 7 is not included. So you're only including in your set 7 point somethings like 7.1, 7.2, 7.3, 8, 9, 10, 11, 12, up to positive infinity. So let us say you have here in the second example, x is less than or equal to negative 3. So we use the number line. Let's say our zeros here, negative 1, negative 2, negative 3. And then we want all the numbers which are less than or equal. So shade this. The numbers which are less than or equal to negative 3 are on the left side. Meaning to say you have here negative 4, negative 5, negative 6, negative 7, negative 8, up to negative infinity. So did you see that? When the inequality sign is greater than, your arrow will be moving to the right. While if your inequality sign is less than, your arrow must be pointing to the left. There. Now what about this? When you graph a compound inequality like this, then you're actually including all numbers from negative 5 there. So you put a shaded hole here. Negative 5 meaning negative 5 is included up to 1, 2, 3. Let us say this is 3. There. All numbers from negative 5 to positive 3. Remember, let us just recall that when we say x is greater than or equal to negative 5 and less than or equal to 3, we're referring to the numbers which are greater than or equal to negative 5 and at the same time less than or equal to 3. So all numbers from negative 5 to 3 here. Now, what if one is greater than and the other one is with equal sign? Now, this would mean that 2 is excluded, but 5 is included. So here, we draw a number line again. Let us say this is 0. Let's say this is 1, 2, 3, 4, 5, and this is 5. So, hollow at 2, meaning 2 is excluded, and then shaded at 5, meaning 5 is included. What about example number 5? What if we are asked to graph a union of two inequalities? Now, this is what you do. You graph each inequality there. So let us say this is 0. And this is negative 4. Graph the first one, greater than or equal to negative 4. So all numbers from negative 4 to the right. and let us say this is 3, graph x is greater than 3, numbers to the right excluding 3. That's why you use a hollow here. Now you're taking the union, that would mean you're combining all the numbers. What do you see? All numbers to the right of 3, combine it with all numbers to the right of negative or equal to negative 4. So you get from here to here. So that would be x is greater than or equal to negative 4. There, that is your answer. Let's check. So, if we combine this, are we getting the numbers which are greater than or equal to negative 4? Yes. Now, what if you change the union to intersection? Now, let's go back to this. X is greater than or equal to negative 4. It is this graph from negative 4 to the right. Intersection or and. When you see the word intersection, it means and. Union means or. And x is greater than or greater than 3 there. So intersection would mean you are getting the common element. So that would mean you're just getting the intersection or where the two graphs overlap. So that they overlap here greater than 3. So that this would mean the intersection is x is greater than 3. There. That's the difference. Now, let's move on to example 7. X is greater than 15. So, let us say this is 0 and this is, let us say 15. There, let's say that's 5 and this is 10. X is greater than 15. Hollow here, pointing to the right. And x is less than 15. Hollow again here, and all numbers pointing to the left. We want the end or the intersection. Is there, do you see an overlap? None, right? They didn't even overlap here. So the intersection is empty set, none. There's no overlap. There is no intersection. Now let's move on to problem number 8. Again, let me draw it here for clarity. This is again our 15 is here, greater than 15. There. Less than 15, x is less than 15, there. We're taking the union, so you combine all numbers to the right and to the left. What do you see? Everything except 15. So your answer here will be x is an element of R, all real numbers, but x cannot be 15. You can also rewrite this. You can also rewrite this as x greater than 15 or x is less than 15. Let's move on to example number 9. Problem number 9. 5 is greater than equal to x. Union, x is greater than equal to 2 and less than 5. Now, in this case, if you're confused here, you know, many students prefer and understand clearly if x is on the left side, then you can do it that way. 5 greater than equal to x simply means x is less than or equal to 5. There. So you can rewrite it that way so it will be easier for you to analyze. So let's graph this again. If this is 0, let's say this is 1, 2, 3, 4, 5. There. Less than or equal to 5. Shaded, all pointing to the left. That is x less than or equal to 5, or 5 is greater than or equal to x. Then graph this. X is greater than or equal to 2. Here, shaded at 2, meaning 2 is included. And then move until 5. 5 unshaded. 5 is excluded. Get the union, meaning you combine them. What do you see? Combine everything to the left of 5, and after 5 to 2, what do you get? So you get x is less than or equal to 5. There, so this is your answer. Only the numbers from here going there are in the union. Now, what about if we get the intersection? We just change the union to intersection. Remember again, intersection means end. Oh, let me graph that again for clarity. So this is 0, 1, 2, 3, 4, 5. There. 5 greater than equal to x means x is less than or equal to 5. So 5 shaded, and everything to the left of 5, that is x is less than or equal to 5. And meaning intersection of greater than or equal to 2 here, shaded here, and less than 5. And we're getting the intersection, or you find where the two graphs overlap. Where did they overlap? Do you see the overlapping? It's here. There, you see that the two graphs overlap here. So, how do you interpret this algebraically? So this is from 2 to less than 5. So we have here x is greater than or equal to 2 and less than 5. So there's an equal sign to 2, there is no equal sign to 5. So this is now your final answer. I hope I was of help to you. But before we end, let us always remember to add kindness, subtract judgment, multiply understanding equals Mrs. O's good life equation. Don't forget to subscribe. Click the red subscribe and also the bell button. Thank you.